We're now going to apply what we know about quadratics in order to solve some problems. If we see a function written in vertex form, we know that that vertex is either the maximum if we open down or the minimum if we open up. P is the x-coordinate of the vertex. Q is the y-coordinate of the vertex. So we're always going to draw a sketch if possible, and then we know we have either the maximum or minimum value is that Q, and it occurs when the x value is equal to P. So our first type of problem is what we call a number problem. So we're told that two numbers have a difference of 10, and we know that difference means that when we subtract them, we're going to get 10. We're looking for what those numbers are if their product is a minimum. And again, we know difference is subtraction, product is multiplication. Most of the time, it's going to say that you have to do the question algebraically, so we can't just guess and check numbers. We need to go about this systematically. Okay, so let's set this up here. So we're going to choose a variable to represent one of those numbers. And then from that number, we're going to subtract 10 in order to get the second number. So now we are also told that the product of those numbers is going to be a minimum. So we're going to go over here and we're going to say the product of those numbers. So we're going to multiply them together. And we can see once I distribute this n in that we do in fact end up with a quadratic function. Now, if we're told that we have a minimum, we're looking for the specific coordinates of that vertex. So I'm going to convert this from standard form into vertex form. So we know that the C value happens to be 0. And there's two ways algebraically you can go about this. So you can use that negative b over 2a formula to get the x-coordinate of the vertex, substitute it back in and get the y-coordinate. But you're going to find in time that completing the square is actually a little bit faster. So that's what I'm going to do here. So we're going to factor a out of the first two terms, and because it's 1, it's going to be really quick. We're going to take half of negative 10, which is negative 5, square it, and that's going to give us 25. This generates a perfect square trinomial. So when we go to factor that, we're going to have that n minus 5 squared, and then we still have that negative 25 there. So that tells me the coordinates of my vertex are going to be 5 and negative 25. So then I'm going to go back to that original statement we had up top here. So I know that there is a minimum. Because this is positive right here, we know our parabola is opening up. And that minimum product is going to be the y-coordinate of the vertex when n is equal to 5. And we can even go over here and sketch this out. So you can see that in the place of the y, we have a p. So I've labeled my y-axis with p. In place of the x, we have an n. So that means we've got an n here on the x-axis. So I have a minimum. I'm opening up. My product is going to be negative 25, and that occurs when x happens to be 5. Now, we need to figure out what those numbers are. So if we go back to our original setup here, we know that the n is going to be the value of our first number. So n is the x-coordinate, so that occurs at the minimum, which means n is going to be 5. And then I can substitute 5 into this expression. 5 minus 10 is going to give me my second number. So if n is equal to 5, 5 minus 10 is going to give me negative 5. So that tells me that the two numbers are going to be 5 and negative 5. In our next question, we're told that we have a rectangular lot. One side of that lot contains a river. The other 3 sides are fenced off with 80 meters of fencing. So anytime we're given a geometric shape, we want to try to draw this out here. So I'm going to draw, this is the river. I'm going to have a fence here, here, and here. And altogether, I know that's going to be 80 meters of fence. I'm looking for the dimensions. So dimensions are the length of the width and the length of the length for the largest possible lot. So when we're dealing with the largest possible lot in here, that's the area that we're referring to. So the area is our dependent variable. Either the length or the width is our independent variable. So we need to isolate one of them over here. And it doesn't matter which one we choose to isolate. Because L already has a coefficient of 1, that's probably the easiest. So if we want to get L by itself, let's subtract 2w from each side, and then that gives me L is equal to 80 minus 2w. So I can now take what L is equal to, and let's substitute it up here in the place of L. So I'm going to have L, which is 80 minus 2w, and then times w. We now have a quadratic function. Let's distribute in this w to get rid of those brackets, and then we can just rewrite this. Remember, a is in front of the squared term. b is in front of the w term, and c is our constant term, which I'm just going to fill in as 0. Now, it tells us that we're looking for the largest possible lot. So we're trying to maximize our area. A maximum means we should have a negative a value, so that's good. Maximum also means that we need to get that vertex coordinate. So we're going to complete the square. So again, I'm going to divide a out of those first two terms here. So when we do that, we're going to have w squared minus 40w. We're going to take half of that value, so negative 20, square it. Negative 20 times negative 20 is positive 400. So that's going to give us our perfect square trinomial. The square root of w squared is w. Half of negative 40 is negative 20. And then just remember, we also have negative 2 times negative 400 gives us that value of positive 800. So our vertex is going to be at 2,800. And then we also have to interpret what exactly that means. So this is where you might want to draw a sketch here. So in place of the y, we have an a. So we've got that labeled here on our y-axis. In place of an x, we have a w. So we've got that labeled here on our x-axis. And we can plot the coordinates of the vertex. Because a is negative, we know that we're going to be opening down. So we have a maximum value of 800 when w is equal to 20. So we're going to write that sentence down here just because it helps us to interpret that question. So that is the maximum area. It occurs when w is 20 meters. And so then because we need both dimensions, we're going to now substitute 20 meters in for w here and solve for the length. So we can go ahead and do that. We get a length of 40 meters and a width of 20 meters. And now you want to check. So is the length plus the width going to add up to 80? And then when you multiply those two, do we get our maximum area of 800 square meters? And the last question that we're going to look at today is what we call a revenue question. So revenue is the amount of money that a business or a company brings in. Revenue is the amount of money that we're selling each item for times the number of items that we're selling. So if you think about, let's say, cookies, if we sell each cookie for $2 and we sell 10 cookies, we have a revenue of $20. N is going to be the number of increases that we apply. So when we go to set this up, we're going to start by saying, okay, we have two brackets. One is going to be price. One is going to be the number of items sold. Originally, we are selling the cost of tickets to a hockey game at $3 a piece, and we have 800 people that we're selling tickets to. So we're going to say $3 is the price of a ticket, and we are selling 800 tickets. Now, something is going to change. In this particular question, if the price is increased, attendance is going to fall by 100 for every dollar of increase. So remember, N is the number of increases. For every $1 increase, we are going to fall by 100, and I need to put that N there. Number one, this is what makes it a quadratic when we FOIL this out. That's going to give us our square term. Number two, these relate together. So we raise the price by $1, the attendance drops by 100. We raise the price by $2, the attendance drops by 200. We raise the price by $3, so we're saying if we have three increases, 1 times 3, $3, negative 100 times 3, 300 people we're losing. So these work together. Every time we increase, we lose 100 times that many people. There's two things we're ultimately trying to find. We need to figure out what is the ticket price that will result in the greatest revenue, and what is that greatest revenue. So greatest revenue, that's another way of saying what's our maximum revenue. Maximum, we need to find what that vertex is, knowing this is going to be a parabola. It's going to be a quadratic. The first thing I'm going to do is put this into standard form. So we're going to go ahead and FOIL. So we're going to multiply first, outside, inside, last, and then we're going to combine our like terms together. So once we do that, we end up with this quadratic. I'm going to put my A term in the front here. I'm going to put my C term at the end because I know I need to turn it now into vertex form in order to get the coordinates of the vertex. So I'm going to factor this A value out of the first two terms. So 500 divided by negative 100 leaves me with this negative 5n. Half of that, so we have negative 5 divided by 2 squared. So that's going to become a positive. 5 squared is 25, and divided by 2, that's going to give us a 4 in the denominator. We can now complete the square, so we're going to square root that n squared to get n. We're going to take half of that term to get 5 halves, and then remember we have to go negative 100 times negative 25 quarters. So a negative times a negative is a positive. 100 times 25 is 2,500, and then just remember that 100 has a denominator of 1. 1 times 4 is going to give us this 4 down here. And then we still have 2,400 over here. I know I need to combine these two terms together, so my lowest common denominator is a 4. So I'm going to multiply both the numerator and denominator by 4 to keep it equivalent. 2,400 times 4 will give me 9,600. 9,600 plus 2,500 will give me 12,100. Divide that by 4, and we're going to get 3,025. So this is the vertex form for this particular quadratic equation. So I now have a vertex of 5 halves and 3,025. Okay, so again, this tells us that we're going to have a maximum revenue of this much money when n is equal to that. So let's go ahead and write that down. And then always a sketch helps you to visualize what's happening. So in this case, instead of a y, we have an r. So we label the y-axis with that r. Instead of an x, we have an n. So we can put the n here. So we can see that this is our vertex and we are opening down. So the question wants to know, what is the ticket price that's going to result in that greatest revenue? Well, we know already the greatest revenue. So if we look at the revenue, the maximum revenue occurs when y is 3,025. So that is our maximum revenue. In terms of the ticket price, this x-axis represents number of increases. We have to substitute the number of increases back into the price bracket in order to solve for what the ticket price is going to be. So currently, our ticket price is $3. We're going to add one increase of $2.50 to that to generate the ticket price that will result in that maximum revenue. So the ticket price is $5.50 per ticket, and that will allow us to maximize our revenue. If the question wanted to know how many tickets can you sell when you maximize the revenue, then you would take that value of n, $2.50, and you would substitute it into the number sold bracket.